Hola! We are doing 8.5, solving special systems of linear equations. So this is where we're going to start seeing no solution and infinite many solutions on a graph and on our equations. And so we know that one solution is where there's one point of intersection. It's where the lines intersect at one point, right? There's a no solution. We've seen this. It looks like a parallel lines, right? There's no point of intersection, so that's why it's no solution. And then we've seen in infinite many solutions, it's where all of the points intersect, right? They look like one line, and so they technically intersect everywhere, okay? So we're going to solve this system of linear equations by substitution, but we're also going to do it by graphing. So I know it says by substitution, but I want to do it on the graph as well so we can physically see it and know what it would look like, okay? Thankfully, these are pretty simple equations, so solving by graphing won't be that big of a deal either. All right, get my, so we can solve these for any of these variables, right? We've got 1, -1, -1, and 1. So it really doesn't matter which one I solve for. I'm going to solve for this x just by adding y right here. And so for my step 1, sorry, I just put lotion on and now my pen sliding out of my hand. I would get x equals y minus 2. So for my step 2, I'm going to take this and plug it into x. I'm just going to go right there. Now remember from class, we need to make sure we put that negative first and then parentheses and go y minus 2. Because I solved for x, and this is very specifically asking for opposite of x. So now I have to take the opposite of everything of my x. All right, and we're going to have plus y equals 4. So I'm going to distribute by a negative. I get negative y plus 2 plus y equals 4. And I have a negative y and a positive y, so they actually cancel each other out. And I get 2 equals 4. And 2 will never equal 4, so we're done. This is a no solution. So that's what makes substitution just as easy with equations, is that you really only have to do 1 or 2 steps and you're done. There's no substituting in for the third step. Okay, so for when it becomes a no solution, we will not have a third step. All right, I do want to solve these by graphing. So I'm going to solve both my equations for y. So if I take this first equation, x minus y equals -2, I will have to subtract x. Get negative y equals -x minus 2. And then I'm going to divide by a -1. I'm going to divide everything by -1. And we'll get y equals x plus 2. So I'm going to go start at plus 2. The slope's just 1, and it's positive, so I'm just going to go 1, 1, 1, 1. And then I'm going to go the other direction. Now, I do know this is a no solution, and so that means I better have a set of parallel lines. If I don't have parallel lines, then I did not graph these correctly. So my other equation, I'll do it down here. We have -x plus y equals 4. I'm just going to add x. This one's a lot easier. And we're going to get y equals x plus 4. So come up here to plus 4. And there it is, the same slope. So oh, definitely didn't connect my lines. But there is my parallel lines. So for no solution, they're going to have the same slope. But if you notice, they have different y-intercepts. Okay, so that's what's going to go with a no solution. Same slope, different y-intercept. And they'll be parallel lines. All right, let's go to the next example. Ignore the fact, I think I cut this out for you guys, but ignore the fact that it says by elimination, because we're not going to do that. We're going to, again, do this by graphing and by substitution, just so that we can see what it looks like for both situations, okay? So this one's a variable 2, or coefficient of 2. This one's a coefficient of 1. This is a coefficient of 4 and a coefficient of 2. Since this is the 1, I'm going to want to solve for this y right here. I'm going to do that by subtracting 2x from both sides. So for step 1, I'm going to get y equals negative 2x minus 2. What's really nice is that's actually already solved for slope-intercept form. So I won't have to solve it again for over here when we graph it. So that's kind of nice. All right, step 2. I'm going to take just this expression and plug it in for y. So I'm going to get 4x plus 2 parentheses negative 2x minus 2. Remember, I put the parentheses because I need 2 of them, and I only solved for 1 of them, and this is a negative 4, and I accidentally covered it up. See, negative 4. I'll move my arrow. There we go. All right, we'll distribute by 2. I'll get 4x minus 4x minus 2 equals, oh, nope, 2 times 2 is negative 4, sorry, equals negative 4. 4x minus 4x cancels. I'm left with minus 4 equals negative 4. These will always equal each other, and that's an infinite number of solutions. So we're going to graph them. This one's already solved for me, so I'm going to put that in there. I'm going to go negative 2, 1, 2. My slope is negative 2 over 1, or 2 over negative 1, right? So I'm going to go down 2, right 1, down 2, right 1. And then I'm going to go back. I'm going to go up to left, or left 1, up to left 1. And now I have a line that is going down from left to right, as it should. I'm not doing a very good job connecting my dots because it is a negative slope. Now, I do know this is an infinite number of solutions, but I am going to go and solve my second equation for slope-intercept form. So 4x plus 2y equals negative 4. I'm just going to show you that it will end up being equal to this. I'm going to minus 4x. We're going to get 2y equals negative 4x minus 4. That's not a very good 4. I'm going to divide by 2, but remember we're going to divide both of these by 2. And look, y equals, well, negative 4 divided by 2 is negative 2x. And negative 4 divided by 2 is negative 2. And there it is. So that means this line goes with this line. And again, for you guys, it'll look like one line, but because I have 2 different colors, I can color over them. So if we notice for infinite number solution, it's going to be the same slope and the same y-intercept. Everything will be the same. Okay, so no solution with same slope but different y-intercept. For infinite number solution, it's same slope, same y-intercept. All right, we are going to solve these just by substitution because they are a little harder. Notice, you know, these are a lot of numbers. And it's a really good time to start solving some of these that don't have these perfect ones or negative ones. And so trying to decide which one would be the best option. So if we look at this very first one, number 6, you can see that there is nothing, none of them have a 1 and none of them have a negative 1. So now our option is, I always like to start with the smaller numbers, and then I really like to keep everything as positive as I can. So what I'm going to do is I'm actually going to solve for this y right here. And the reason why is it allows me to add 2x. That makes it positive. I get 3y equals positive 2x plus 4. And then I just divide by 3, and I get y equals 2/3 x plus 4/3. And I know that seems sucky because they're all fractions, but at least everything's positive. So that's how I like to look at that, is that at least now everything is positive. So I'm going to take that. So that was my step 1, right? Step 2, I'm going to take this and put it in for y here. So it'll be 4x minus, I'm going to do 6/1, just because what I know I'm substituting in has fractions as well, plus 4/3. And I'm going to set it equal to 9. So I have 4x minus, this is a negative, so 6 times 2 is 12, and 12 divided by 3 is 4. So this actually just comes out as negative 4x. That was nice. And then negative 6 times 4 is negative 24, but 24 divided by 3 is negative 8. So again, that was kind of nice that they cleaned up and everything was the same. Well, 4x minus 4x is just a cancellation, and I'm left with negative 8 equals 9. And that's a no solution. So even though there were fractions in there, they ended up being kind of nice because they cleaned up. Okay? All right. Let's do what they say is number 7. So this time we actually can solve for a variable of 1. All right, so I'm going to subtract 2y right here. There's my step 1. And I get x equals negative 2y plus 6. So that was nice and easy. So we're going to take that and plug it in for x right here. So step 2 is 2 parentheses negative 2y plus 6 minus 3y equals 26. So we distribute by 2, and we get negative 4y plus 12 minus 3y equals 26. So if we combine these, we actually get negative 7y plus 12 equals 26. Minus 12, we get negative 7y equals 14. Divide by negative 7, and we get that y equals negative 2. So this time we actually are going to complete this. This means this is going to be a one-step solution, or one-step equation, or not one-step equation, one solution equation system, because I do have an x and a y. I'm going to plug it in right here. It's going to be x plus 2 times negative 2 equals 6. We're going to get x minus 4 equals 6. We're going to add 4, and we get x equals 10. And so our final solution is then 10, negative 2. And this is a one solution. All right, so the next one, again, we don't have anything that we can solve for easily. So again, I like to keep things positive and stick with my smaller numbers. So I'm going to solve for this y, because these are my smaller numbers, my smaller coefficients and constant, and I'm going to add 3x, which then causes it to be positive. Okay, so those are the kinds of things I like to look for when I am solving for something that isn't a coefficient of 1. So I'm going to get 2y equals 3x plus 1. We're going to divide by 2, and we're going to get y equals 3 over 2x plus a half. Now, just like this equation, we had some not nice fractions. Hopefully these ones will clear as well. We're going to take this and plug it into this y right here. So step 2, I'm going to get 12x minus 8 over 1, just because again I'm multiplying by fractions equals -4, I'm going to get 12x minus, well, 8 times 3 is 24, and 24 divided by 2 is 12. And we're going to get minus here as well because it's negative and a positive. 8 times 1 is 8, divided by 2 is 4. And we're going to get -4. Well, 12x minus 12 cancels, and we get -4 equals -4. And as we saw from our first couple of examples, these are exactly the same. So this is infinite number of solutions. So even though we dealt with fractions, it was nice and easy because they went away. Don't always get scared of those fractions. All right, so the main things to remember are kind of these little notes I wrote here, right? Same slope, same y-intercept, same slope, different y-intercept, and then for one solution, it'll be same slope, different slope, different y-intercept. So those are the things I think I'm going to type right here, main things to remember. So no solution, same slope, different y-intercept, infinite solutions, same slope and y-intercept. And then for space for me, I'm going to put this one up here. One solution, different slope, and y-intercept, meaning they're both different. So one solution is different, different. No solution is same, different, and infinite solutions is same, same. All right, so for your independent practice, you're just going to state the number of solutions that each of these have described. So you can draw a picture if you want, but it's just asking what would the solutions be if this information was given to you. So you don't have to even solve anything. That's kind of nice. All right, until next time, adios.